Although you may have learned before what a ratio is, I just want to do a quick review of what it means and different ways of writing them. Okay, so you probably learned in the past that a ratio is just an association between two or more quantities. A lot of people think of them as fractions, but they're really not fractions. You can write them in lots of different ways. So let's look at this picture for a second. And it says, what's the ratio of triangles to circles? So if you want to do triangle to circle as ratio, you want to count the triangles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And the circles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's the ratio of 9 to 15, which is the triangles to the circles. Now the thing about ratios is that they can be simplified as much as you want, right? So 9 to 15 is really the same as 3 to 5. And I think that's one reason people like looking at them as fractions, because you could say 9/15, 9 out of 15 is the same as 3 out of 5. Okay? So you can write it either way. I think people like to think of it this way better, just because you have knowledge about fractions in the back of your head, and it helps to see what equal ratios actually means, right? 3 out of 5 is the same as 9 out of 15, that ratio. So sometimes ratios are actually out of the total number of objects that are there, right? So here, if we want the ratio of total objects that are the moons out of the whole thing, so you count how many moons there are, which is 2, out of the total number of objects, which would be 1, 2, 3, 4, 5, 6, 7, 8 times 2, which is 16, 2 out of 16, or 2 to 16, which is equivalent to 1 out of 8. So that's different than asking what's the ratio of moons to triangles, right? That would be 2 to 14, which would be 1 to 7. So that's a really important thing to notice. So you have to think about, you're talking about the parts and the whole here. Here you're just comparing two parts. So it's important to really read the question. Now we're going to apply ratios to a problem. And when we write the problem or try to do the problem, we're actually going to set two ratios equal to each other, and that's called a proportion. So the proportion is when you set two ratios equal to each other. Okay? So in this question, for every 18 French fries Sal eats, he uses 2 ketchup packets. So let's look at that ratio, right? It's 18 French fries for 2 packets of ketchup, right? So that ratio is 9 to 1. 9 French fries for 1 packet of ketchup. Those are equivalent ratios. So if Sal eats 108 French fries, how many ketchup packets did he use? That's the question, right? So how many ketchup packets did he use? So you got to look and say which one of these numbers is representing the ketchup packets. That is the denominator, right? The one on the bottom. I'm going to get rid of that for a second. So this is the ketchup packets, and that's the thing we don't know. So we're going to call that X. And the numerator is the French fries, right? So how many French fries did Sal actually eat? He ate 108 French fries. So I'm going to put 108 in the top because that relates to the French fries that were here, right? The X is in the denominator because that relates to the ketchup packets. keeping in mind that we're looking for the number of packets of ketchup that Sal used with 108 French fries, what we're going to do is look at a table here now, right? And say, okay, so one column is going to be the number of French fries, and the one is going to be the packets of ketchup. Okay, so we know that if he eats 9 French fries, he uses 1 packet. And from the problem, we also know that if he eats 18 French fries, he uses 2 packets of ketchup, right? So you could probably see a pattern that's occurring here, right? So if I add 9, if I have 27 French fries, this is going to be 3 packets of ketchup, right? If I have 36 French fries, I'm going to have 4 packets of ketchup, right? So what we need to do is keep doing this chart until we get to 108. So how many times is that going to be? Is there a way to figure out how to get from 9 to 108? So if you kept going with that table, what you would see is that 9 times 12 is 108. And if you went another 12 times with the packets, you would get 12 packets. So that's your answer, 12 packets of ketchup. Let's just do another one really quick. Here's a similar problem. The ratio of the amount of liquid in 2 containers is 4 to 11. So in container 1, there's like 4 gallons, and in container 2, there's 11 gallons. But it could also be any multiple of that. It could be 8 and 22, etc., right? So if this table is container 1, and this is container 2, we would start with 4 and 11, right? So what are we looking for? We're looking for the liquid in the second container when the first container has 20 gallons. Okay, so what we have to do is go from 4 to 20, right? So it's going to be 4, 8, 12, 16, 20. So we could jump right from 4 to 20 by thinking, what is 20 divided by 4? And it's 5. So we could just say 11 times 5 is 55, but let's actually go through the table and make sure we know what we're doing and we get the right answer, right? 11, so when it's 8, it would be 22. When it's 12, it would be 33. When it's 16, it would be 44. And when it's 20, it would be 55. So the answer is that if one container has 20, then the other one has 55.